Okay, I'm going to record this review. So once again, the question is for this piecewise function, am I plugging -1 into the top or the bottom? I'm getting lots of tops, and that's correct, isn't it? All we have to do is just ask ourselves, the x value, -1 that I'm plugging in, which one of these is true for -1? Is -1 less than 0, or is -1 greater than or equal to 0? Well, it's less than 0, right? So this definitely goes in the top piece. And so then in the top piece, every place where I used to have an x, I'm going to plug in a -1. And so what do I get? -5 plus 4 is going to give me -1. So f of for this piecewise function, f of -1 equals -1, right? Everybody see that? Okay, what about the next piece? We'll make this one green. F of 0. So tell me, top or bottom? Top or bottom for that one? Am I plugging 0 into the top or the bottom? Okay, yeah, that's going bottom, isn't it? It's going bottom because 0 is not less than 0. 0 is greater than or equal to 0, right? It's equal. That bottom piece includes the equal sign. So then every place where I have an x in the bottom, I'm just going to plug in a 0. So 0 plus 5 equals 5. So we end up with f of 0 equals 5. Okay, last one. Whoops. How about f of 1, top or bottom? Okay, good. That's going bottom, isn't it? Because 1 is greater than or equal to 0. Okay? And so if I plug this into the bottom piece, let's see, every place where I used to have an x, I'm now plugging in a 1. 1 plus 5 equals 6. So f of 1 equals 6. Good. Okay, let's try one more of these. How about this one? Okay, so we got another piecewise function with two pieces. There are two rows to this. Okay, so let's look at h of 3. Top or bottom? Top or bottom? Which piece does that fit into? Okay, now let's think about this one. What's the domain of the top piece? So all of the x values that are not equal to 4 get plugged into the top, right? If x is actually equal to 4, then we plug it into the bottom. So what do you think? H of 3, am I plugging 3 into the top or the bottom? Okay, yeah, it's going top, isn't it? Good, that's going top. Because we can see up here that 3 is not equal to 4, so that's going into the top piece, isn't it? Okay, and so what's that give us then? Every place where I have an x, I'm going to plug in a 3. And what's that give me? 3 squared is 9 minus 16 is -7. 3 minus 4 is -1. -7 over -1 is +7. So then we know that, let's see, this is, it's not f, it's h, isn't it? So h of 3 equals 7. Okay, I got a question for you. So if I wanted to write that as an ordered pair, h of 3 equals 7, how would I write the ordered pair? Type that in chat for me. Yeah, that's right, isn't it? Because 3 is the input, so that's got to be the x value. 7 is the output, so that's the y value. Good, so that would be the ordered pair 3, 7, which also tells me that if I were to graph this thing, the point with coordinates 3, 7 would be on my graph, okay? All right, let's try the next one. How about h of 0? Actually, let's skip that one. Let's just do, well, we'll do it real quick. H of 0, does that go top or bottom? Does it fit into the top x values or the bottom x values? Ah, okay, good. That's top, isn't it? Right? Fits into the top because it's true that 0 is not equal to 4. So it goes into the top. So that's going to give me, let's see, 0 squared minus 16 over 0 minus 4 equals negative 16 over negative 4. Well, that's positive 4, right? Negative over negative is positive. So h of 0 equals 4. Okay, last one. How about h of 4, top or bottom? Top or bottom? Okay, yeah, that's looking like bottom, isn't it? Because look, 4 is equal to 4. So that goes into the bottom. That fits in the bottom. And what's my output for the bottom? Well, there's no place to even plug an x. The answer is always 5. So h of 4 equals 5. Okay, probably last thing that we'll get to look at today, and this is good for today. Let's look at think about the graphs of piecewise functions. Okay, so I've got these two pieces here in this piecewise function. The top piece is the line y equals 2x plus 5, and the bottom piece is the line y equals 1/5 x plus 3, right? Okay, now look at the domains here. We're graphing the top line when x is less than or equal to 0, and we're graphing the bottom line when x is greater than 0. So we can see right away here that 0 is the boundary between the two, isn't it? Right? Right? 0 is going to be the transition. When x is 0, that's when we're transitioning between those two lines, right? So let's just see which of these pieces is going to fit, first of all. Well, look, all the pieces, they do the right thing in terms of the transition. X equals 0 is where we're jumping between the two lines. So that part is correct, isn't it? Let's look at this top one, though, and see if this one works. So there's my line, right? Let's do... Let me see something here. Can I do... Oh, hang on. Okay, so there's my boundary line, right? That's in the right spot. Let's see if the other parts are, though, right? So we know that when x is less than or equal to 0, we should be graphing, we'll make this our blue function, we should be graphing the function y equals 2x plus 5. Okay? And when x is greater than 0, we should be graphing the function y equals 1/5 x plus 3. Okay? Let's see if that works. Well, let's check this line. for the blue line, type in chat for me, what are the values of the slope and the y-intercept, M and B, for the blue equation? Y equals 2x plus 5. What are the values of M and B? Slope and y-intercept, right? And I don't mean the graph, I just mean this equation right here. Based on that equation, what should the slope and the y-intercept be? I want to hear from everybody. Quick. Okay, so we should get M equals 2 and B equals 5. Well, let's see if that's working. So what are the coordinates of this point right here? The y-intercept, right? Well, it looks like the y-intercept is up 5 because we're going by 2's, aren't we? Look, that's 10. So each of these little dash marks is 2. So I'm going up 2, 4, 5. So I have the point 0, 5. So we're checking off that is the right y-intercept. What about the slope? Let's see if I get another point here. What if I pick this point like, how about this point right here? What are the coordinates of that point? It looks like the coordinates, I'm going by 2, so I'm going back 1 and up 3. So -1, +3. So sure enough, look at my slope triangle. I'm rising by 2 and running by 1. So yeah, my slope is 2 and my y-intercept is 5. That checks out, right? How about this other side over here? Let's check this point. Okay, that's a solid point. So that point right there has coordinates 0, 3. So yeah, we're checking off. Shouldn't this one over here, shouldn't this have a slope of 1/5 and a y-intercept of 3? And we check off the 3, don't we? It's got the right y-intercept. What about the slope? I'm rising by 1 and I'm running by 2, 4, 5 to get to that point right there. So yeah, the slope is 1/5. Okay, so did it work? Sure seems like it worked. Is there anything wrong with that? With that top one? Anything wrong with that? Does it fit? I see one tiny mistake. The lines have the right y-intercepts and slopes, but what's wrong about that graph? Right, look at our piecewise function here. Something doesn't fit. I gave you a hint there. Ah, okay, the endpoints. Yeah, look, the top endpoint for the blue line, it includes the equal sign. So that's the one that needs a closed endpoint. And look, for the red line, we don't have an equal sign, so that should be an open endpoint. So this one doesn't work, does it? We just need to find the graph that has the same lines but opposite endpoints. And that's it right there, isn't it? So this is the right one, isn't it? Right? Everybody see that? So that's our choice. Hey, that's timing right there. How about that? Okay, good enough. I am here after school if you need me. Otherwise, if I don't see you, have a great long weekend, and I will see you on Tuesday. So be working on the review assignment, 3.5, then move on to the review assignment. Practice tests are up there. Test is Thursday unless you want to do it earlier. All right, have a great weekend.